So good morning and thank you for joining us today for our webinar as we take a look at SolidSteel parametric inside the SolidWorks user interface. Today, our webinar will be led by Sebastian Kielch, a General Manager at SolidSteel, and Connor Houghton, our Senior Account Manager at CAD Micro. Before I hand things off over to them to kick us off, there are a couple quick housekeeping items to mention. First, as usual, we'll save time at the end of today's session for a quick question and answer period. Feel free to type your questions in the GoToWebinar panel as they come up, and we'll do our best to get to them by the end of the webinar. Today's webinar will be recorded, and we'll be sending you the recording via email tomorrow. So if any questions do arise afterwards, you can feel free to respond to that email, and we'll be in touch shortly. Okay, so without further ado, I will pass things over to Connor to get us started.
Thank you, Sarah, and welcome everyone to the webinar on utilizing SolidSteel in SolidWorks for structural steel design. And thank you for joining us today. My name is Connor Houghton. I'm an account manager here at CAD Micro, and I'll be going over a little bit of the schedule and today's topics on the webinar before I pass it off to my colleague Sebastian, who's with SolidSteel, and he'll dive into the software itself for a demo and a direct look at the functionality. So the reason you're all here today is to answer the question, what is SolidSteel? And to put it simply, it is a parametric steelwork solution that is 100% integrated with your 3D CAD tool SolidWorks. It has been developed, maintained, and supported by a German company since 1973. I try to pronounce the name entirely in German, but I'd embarrass myself and I wouldn't come close to getting it right. Sorry about that, Sebastian. SolidSteel is a certified gold partner of SolidWorks, and you may have seen that logo before up in the top right-hand corner for gold partners. But what does that really mean? So a gold partner means its functionality is integrated with SolidWorks, and it is required to keep up with service packs as they are released by SolidWorks, as well as maintain ongoing customer support for their users. And in this case, you can see with the screenshot there of SolidSteel, it is fully integrated into SolidWorks, just with a tab there on the top. And you may notice the version of SolidWorks is in German, so I'll answer the question before they come in. Yes, SolidSteel is supported in English as well as many other languages. So the main target industries for the software is going to be classic steelwork design, as well as plant process engineering and mechanical engineering. It allows you to automatically create complex constructions and bolted connections while conforming to various standards from around the world. This includes American standards, European, Russian, and their profile of standards are being expanded on each year. So what we will cover today in the presentation will be the following. An extensive range of profiles and libraries, including as well as how they can be customized and expanded. Your typical steel connections, which include end plates, gusset plates, ribs, fish joints, bolted connections, clip angle connections, frame corners, and many, many more. This also includes a database of thousands of screws, nuts, bolts, washers that doesn't require you to use Toolbox. The creation of industrial stairs, platforms, supports, handrails, and automated calculations for those step placements in your stairs. Again, these libraries of designs for these things, stairs, handrails, so on and so forth, are all customizable. Automation, creation of drawings, parts, and assemblies, DXF sheet metal exports, bill of material exports, and all the custom properties that go with that. Exporting to NC data for manufacturing in DSTV format. We'll go over the compatibility of current SolidWorks simulation capabilities as well. And we'll finally go over the requirements to actually run SolidSteel. So as Sarah mentioned before, We will have a question period at the end to go over any questions that come in along the way. So just use the chat in the right-hand side to ask any questions, and we'll try to get around to them either in the webinar or we'll answer them in an email afterwards. And so with that, I'd like to pass the lead over to Sebastian so he can jump into the software himself.
Thanks for the introduction. I don't have any slides for you anymore. We directly jump into the software. Here we have a part, and in this part we have a standard SolidWorks sketch. You can edit it, so it's an usual sketch, you know that. In the next step, when we want to start our steel design, we have to create a new assembly, because with SolidSteel we work on assembly level. So we are not using the multi-body parts from SolidWorks weldments, for example. So we want to create a new assembly, and we add our control sketch here. Just start it. For example, a new number, and save, yes. Okay. Now we have our sketch here, and we want to create some beams. We have different international profile libraries containing different international standards. The library is also extendable by yourself, so it's very easy to handle. In this case, we want an I-beam, and you can see we have all the types, all the sizes. When we select the system line, we get a preview. We want to rotate this one. Say, okay, I pin the PMP. And this, in this case, I want it to go down like this. Okay. So first of all, we have our two beams. And here you can see each beam is an individual part inside of the assembly. Okay, in the next step, we want to take a look on how to connect those beams. First, I will do a cut. In this case, it's you will see later why I'm doing this. So just do the cut. Nothing changed, of course, because we cut on this face. Next step, we want to add a typical steel connection. In our example, an end plate. Just select the beam and a surface we want to connect with. Then we get a preview. The preview is usually sized by the bounding box of the source beam. And of course we have different end plate standards in delivery. And of course you can create your own standards if you want to. The bolts are also stored in the standard or can be selected manually down below. But in this case, I like this end plate and I want to create it. When the end plate is created, the beam will be cut off, the end plate will be placed, and also the bore holes will be placed automatically without anything to do. What we also have, we have a welded component sub-assembly. So it's a sub-assembly with all parts which are welded together. So in this case, we have the beam and of course the end plate. The other beam, I will open it for you. We can also see that there are the bore holes, and it's not an assembly feature, it's a part feature, and it's an usual cut feature. And you can see there are no external references inside of this part, and that's the reason why we can keep the performance high even in larger assemblies. But don't worry, it's still parametric by 100%. We will see that later. Alright, in the next step I just add some stiffeners or ribs, just selecting the beam and an edge, for example, then switch the reference edge. And yeah, of course we can change the stiffness in any ways, but in our example I will just keep it in a standard and say okay, please create these ribs. Again, the ribs will be created automatically, and also the welded sub-assembly will be created automatically by the system. It's an option, so if you don't want these sub-assemblies, you can just disable the function. It's everything is possible to do this user-defined. Okay, so now we have our design here. It's a very easy design, but for our example it's perfect. I just started, and as I've mentioned before, I told you it's full parametric. So in this example I want to show you 3 different types of changing the design. Just checking to-do list is empty, and then first of all I want to change this beam, and I say I want it bigger, for example 280. The red marked are all the connections which are influenced by the change, and now we can see here it's not looking good, but when we enter our to-do list we can also see, please check the cut, the end plate, and also the both ribs. In this case, first of all I check the end plate. It's because I don't want to recalculate everything automatically, because I'd say I need a new end plate, it's not big enough anymore. So I just can say change this end plate, and we got the new size. We can also select the new standard, then we get bigger bolts. Say okay, and now everything is back in place, but not everything. The stiffener is on the wrong side, so we can just hit the update button and SolidSteel parametric will recalculate everything. The position, in this case it's just the position of the stiffener, but here we go, it's done. If the end plate had the correct size, we just had the possibility to hit the update button at the beginning, then everything also on the length of the beam would be calculated automatically, but I wanted a bigger end plate, so I decided to make it before. The next step, I want to change this beam because it's a little more complex. I want to also a 280, and here we see nothing fits anymore. The stiffeners are too small. The end plate is here's a collision between the beam and the end plate, so just hit the update button again and everything will be recalculated. In this case the size of the stiffeners, the position of the end plate, the beam will be cut off again, and so here we have an better fitting design than before. So everything will be recalculated automatically, and we still have a full parametric system. All right, the last step I want to show you is when we change the sketch. We can change, for example, the angle. Of course we can also change the length of the beams and everything, but in this case I just want to change the angle. And now you can see nothing happens. As I've mentioned before, we don't have any mates, we don't have external references between the parts. So we just say hit the update button and everything will be recalculated the way we need it in the new situation. All right, here we go. And it's done. Here you can see there's a 10 degrees angle now. The beam is cut off in a 10 degrees angle. And so yeah, it's very flexible. You can use it in any ways. Okay, I just started again, and now I want to show you a few of the following processes. All the different steel connections we have here will be topic in another webinar. So this is just a rough overview about the software. We are able to create thousands of different steel connections, so it's nearly everything is possible. And if you have any questions about these steel connections, don't hesitate, please send us an email or contact your salesperson, and then you will get an answer or an example. Okay, in the next step we want to take a closer look at the following processes. So first of all, we want to create bill of material. We can do an Excel export, for example, and we can create different kinds of bills of materials. In this case, I have the German names for the templates here, but everything is template driven. So you must keep in mind that everything or every layout of the bill of material you need is possible to create. I just create an usual bill of material. Stückliste is the German name for that. And I just select a header for the bill of material and select a place where I want to store that, for example on my desktop, and I call that demo bomb. Save. Also assigning the position numbers and create it. What the software is doing now, we have a detection for identical parts. So when we have bigger designs, it's very common that there are identical parts inside of the design, and of course they need the same position number. So we check the geometry of every part inside of the assembly, and then the position numbering will be done automatically. It's also possible to do the numbering manually, but the bigger the designs, the more time you need. We check out the result, just going to my Explorer, and here we have the demo bomb. It's a standard Excel file, and just making it a little smaller. Okay, here we can see the result. First of all, a list where everything we have the beams, the plates, and the bolts. We just have a sheet list here. It's sorted by the thickness of the plates. We have a profile list. In this case, we just have one size, so it's just one block here. We have a structure list. In this example, it's the top level of our assembly. There are just the bolts. We have both sub-assemblies. Both are welded assemblies containing, in this case, the beam and the end plate, and the beam and the force stiffeners. And of course, we also have a cut list. It's as the name says, it's a cut list. So we have the description from both views of the beam, how to cut this beam. Okay. Of course, all the bills of material information are also available in SolidWorks. So if you have an existing process for the bills of materials, for example, in your PDM or ERP system, that's no problem, because all of the information are stored in the part properties of each part. In next step, we want to take a look at the drawing functions, and there we have, for example, a DXF export. We can create the DXF files of all parts inside of the assembly, or just of selected components, for example, the end plate and the stiffener. We can add an order number and store that on my desktop, say OK. Now the DXF files of all the parts will be created automatically. There's nothing you have to do. Of course, if you have a large assembly or a bigger assembly with hundreds or thousands of parts, this process takes some time, but it's still full automatically, so you can go for lunch, for example, and when you're back in office, yeah, all DXF files or all drawings are done. Okay, we check out the result again. In this case, going to my desktop, here is a folder with our order number, DXF export. It's sorted by the thickness of the plates, and inside there is the DXF file. I just open it with my e-drawings. Because it's sorted with the thickness of the plates, it's very easy. You just can pick up this folder and yeah, hand it out to your manufacturing machine, and that's it. Yeah, here it's the result. Okay. Next step, we want to take a look at the drawings itself. So we have different possibilities. We can do drawings for the welded component assemblies, for the assembly itself, or just a drawing, yeah, about some components. In this case, I select this beam, for example, and the end plate, selecting an usual SolidWorks drawing template, and again our order number. The order number can be filled out automatically from an ERP system if you have one, and say, I'll start it on my desktop and say OK. Now all the drawings will be done again automatically. You don't have anything to do. All the dimensions yeah, will be placed, and important, it's not the automatic dimension functions from SolidWorks. It's an individual one, so we just have the dimensions we really need for manufacturing. So I just open the drawing. Here we have the different types. It's a beam in this case, and say OK. Here we have the result, so it's, yeah, everything we need. Okay. That's it for here. It's a rough overview about the general functions. In the next step, we want to take a short look into the stairs and handrails functionalities, because it's a, yeah, real time-saving machine. So just quitting this, and then I open this sketch here. And yeah, no worries, we don't want to create the entire staircase in this webinar, but I just want to show you how to create a stair and the handrails for this. Again, the same procedure, creating a new assembly, placing our sketch inside of the assembly, and start it again, for example, again with a new number. Say OK. Here we go. Of course, we have the possibility to create new sketch lines, placing all the beams on the sketch lines, and yeah, placing then our stair steps and so on. But of course, it's not the way you want to work. It's not the way we want you to work, and for this reason, we have a special function for the stairs. To create a stair, it's super easy, just selecting and start and an endpoint for the stair, and then we get a preview. And of course, we can edit this stair in any ways. We can choose the beams for the stingers. We can choose different steps. There are different steps in delivery, but also you can, yeah, create your own stair step library if you want a wooden one or a glass stair step or whatever you want. It's possible to add it into this library. We want to configure our yeah, stairs, and here we have all the different dimensions. We can create an offset, for example, like this. We can create extensions, for example, we want a horizontal one at the top with 1400 millimeters and a vertical at the bottom 180 millimeters. Now we can see all our calculate numbers are black, so there's nothing to change. We want an additional stair step at the bottom. For example, we can also add offsets if we get some changes in the ground heights or something like this. We can add offsets, and then all the stair steps will be in their right position. Close this and say I like it like this and want to create it. Of course, this process takes some time, but keep in mind that or what the software is doing. We are creating 6 profiles. We are doing all the miter cuts between those profiles. We are creating the welded component sub-assemblies. For the stingers, we are creating the stair steps and placing the stair steps, all the bore holes and all the bolts, of course. So I'm really not sure. I think it's less than 1 minute to create such a stair. So it's really good possibility to save a lot of time in your design process. And here we are just disabling the sketch, and we have the stair steps, we have the bolts, and everything we need. Okay, in the next step we add a handrail. The handrails are template driven, so there's nearly everything you can imagine is possible. It's an usual SolidWorks assembly, so the template is an usual SolidWorks assembly. When we insert a handrail, just selecting a surface and an edge, we get a preview of the bounding box of the template file. Just creating some offsets for the placement, and I guess it's 50 in this direction. Okay, here we go. In this case, I select my template and say okay. What he's doing now, we are creating an independent copy of the original template. So the original template will not be touched by the software, just doing a copy, and all the changes we can do on this template will not affect the original template. So it's quite fast. Here is the result. In this case, I say, no, I don't like it this way. So I can, of course, change it, and we are working with these SolidWorks equations in this case, and we can select it, and the software finds all the equations we have in our template. And now I can say I just want 2 segments, but 9 rods in it, and say okay. And then everything will be recalculated. It's quite fast, and here's the result of our new handrail. In the next step, of course, we can create another one here. Whoops, sorry. Starting this again. This face and this edge. Again, 50 this side. In this case, 50 in the other direction, and 50 here. Creating this. Again, the original template will be loaded and the copy is done. And so in this case, again, we have those 4 segments. Of course, when you know, usually my handrails just have 2 segments or 3, then just create a new template or change the template. You can change the equations inside of the template the way you need, or you can just store different templates. In this case, it's not the result we want to have, of course. Just say I want one segment and, for example, 10 rods in it, and say OK. Again, will be recalculated, and here's the result. So to make it a little more beautiful, we can just suppress this one and also this one. I can do it here. This one, and here we go, then just doing a new face cut, this face, this beam, say OK. Down below there's another one. I need this one too. This direction, say OK. And the last step is to do a miter cut here, cut with beams, miter, this beam, and this beam, say OK. And of course the miter cut will be done. And here we have our result. It's a very easy way to create stairs and handrails. And if we imagine the standard or the typical designs in structural steel, it's a lot of different steel connections. As I've mentioned before, there are thousands of possibilities to create the steel connections. Even template-driven connections are possible. So if you have a very individual connection type, including a hook for a crane, for example, or whatever, just create a template and you can use these connections all the time. So from my side, I'm done. I thank you very much, and now we are available for your questions, and we are happy to answer all your questions. Thank you.
I do. So as mentioned, we have time for questions. So if you have any questions, please enter them into the GoToWebinar panel now. But as Connor mentioned, we have a few in the queue. So let's go ahead and get started. And Connor, I'll direct the first question towards you. So the question is it possible to open an assembly designed with SolidSteel parametric on a workstation without a license for SolidSteel parametric?
So yes, it is possible because SolidSteel doesn't have any special or unique assemblies or parts. SolidSteel parametric is creating the usual and native SolidWorks parts, assemblies, and sub-assemblies.
Fantastic, thanks Connor. The next question here I think is for Sebastian. And the question is, do you offer network/floating licenses?
Yes, we do. We just offer network licenses, and including the license prices, also the license server included.
Awesome. And the last question I have here, I think is also for you, Sebastian, is can I add a normal SolidWorks part to the structural steel design?
Yes, of course. It's basically the same answer we had in question 1. It's SolidSteel creates nothing special. It's a native and usual SolidWorks assembly, and you can create your own parts. Or of course, you can also add existing components just using the standard SolidWorks assembly functions.
Awesome. So I think that's all the time we have for today. If any questions do arise after we finish here, please do not hesitate to reach out to your account manager or reply to the webinar email that you will get afterwards, and we will definitely be in touch with you. So once again, thank you for such a great presentation, Connor and Sebastian, and thank you all for joining us this afternoon. Please stay safe and healthy, and we hope to see you again soon. Thank you.
Thank you.